Okay, we'll be learning now why the earth has seasons. So we know that some sort of situation we know about aphelion and perihelion. So the aphelion is actually furthest from the sun and perihelion is actually closest to the sun. But is that the reason that we have season? No, actually not. So the earth revolves completely around the sun in an elliptical path, not quite a circle, but elliptical path, in about 365 days and 6 hours. That's 6 hours for 4 hours. 4 years actually make the one day more. That's what we call leap year. As Earth revolves around the sun, it spins on its own axis. And completely one spin in 24 hours a day, we call it rotation. The average distance from sun to the earth is 150 million kilometers, so 93 million miles. Because of the earth orbit is an elliptical instead of a circle, and earth is slightly off center from the sun. Well, the actual distance from the sun to the earth varies during the year. The earth comes closer to the sun in the month of January is all about 147 million kilometers. Then it's the earth goes like in the July 152 million miles away. So from this observation, what does we learn actually? From this observation, we might conclude that our warmest weather should occur in January and our coldest weather in July, but it's not. So in the northern hemisphere, we normally experience cold in the month of January, and in the southern hemisphere, actually we experience hot. But when we are closer to the sun and warm weather in July in the northern hemisphere, we are farther away. If nearness to the sun were the primary cause for the season, indeed, the January would have the warmer than the July, but it's not. However, the nearness to the sun is not the reason for the season that we have. It's not the part of the story. Okay, our seasons actually are regulated by the amount of solar energy we call incoming solar radiation that received at the Earth's surface. This amount is determined primarily by the angle at which sunlight strikes the surface and by how long the sun shines on any latitude during the daylight hour it is striking. So let's look more closely at those factors. Solar energy that strikes Earth's surface perpendicular directly is much more intense than the solar energy that strikes the same surface at an angle. Think of shining a, for example, think of shining a flashlight straight at a wall. You get a small circular spot of the light. Now if you tip or just make it angle the flashlight and notice that this spot of the flashlight actually is spread over a larger area. The same principle holds for the sunlight. The sunlight is striking Earth at an angle spread out and must hit a larger region than the sunlight impinging directly on Earth. So everything else should have been equal and an area experiencing more direct solar ray that will receive more heat than the same area being struck by sunlight at an angle. So in addition to that, the more sun ray are slanted from the perpendicular, the more atmosphere they must penetrate. If the sunlight is angular, sunlight has to pass through the, the thick layer of the atmosphere, and the more atmosphere they penetrate, the more they can scatter and absorbed. So as a consequence, when sun is high in the sky, it can heat the ground to a much higher temperature than when it is low on the horizon. It's an angular situation. Another reason is the important factor that determining how warm Earth surface become is the length of the time the sun shine each day, the number of the daylight hour. So more daylight hour, of course, means that more energy is available from the sunlight in a given location somewhere. More solar energy reaches Earth's surface on a clear and a long day than on a day that is clear but is shorter. So therefore, we can say more surface heating actually taking place there. So for the causal observation, we know that the summer day have more daylight hour than the winter day. Also, the noontime summer is higher in the sky than the noontime winter sun. Both of these events occur because our planet is spinning inclined or tilted on its axis 23.5 degree right of being perpendicular as it revolves around the sun, right? Okay, so these are the reason that we actually have seasons. So in the next video we will be talking about the season, how season happens in different time of the year, and how does this our earth actually is play a role during the season, and also the tiltation plays the important role for the season. We'll be talking that, and that would be important. From this lecture we know what would be the possible question then. Why do we have season? Definitely. Thank you.